All right. Good afternoon, everyone. So, happy Friday sa ating lahat. Kumusta ang pagbabalik galing sa mahaba-habang bakasyon? I hope nasa ACAD mode na ulit tayo. Hashtag sana all kasi parang gusto ko kulang pa rin yung bakasyon, ano. But anyway, we have to move forward and let's go. Nandito na tayo sa home stretch na ng semestre na to. And I think this is the last session ng section ng chapter 2B. So I guess kung hindi ako nagkakamali, next meeting ay si Sir Jomar na uli yung magdi-discuss sa inyo with some certain topics, some methods. So in the span of the few weeks that we had been together, meron lang tayong dalawang basic concepts na natakal. Number one is the methods in linear algebra that can be well applied into data analysis or data science. And ngayon, tinignan natin yung graph theory methods na pwedeng i-apply sa data analysis. Now, there are a couple of, actually not a couple, but I think there are around 4 or 6 more other general topics na nandun sa website ng or sa webpage ng AMAT 255 for chapters 2B and 2C. Tama ba? 2B and 2C yata ito. So we didn't discuss them. So I hope that with the experience we got with discussing numerical linear algebra techniques and graph theory techniques, you will be able to discuss to study those things on your own. So maganda yung nasa website, there are some instructional videos. For instance, there are 2 remaining topics in this chapter na diniscuss yata ni Sir Jomar last semester or binigay niya as a reading assignment. Meron dong paano ka nagkakaroon ng graphical analysis from data. Basically, parang nag-linear regression ka or tinignan mo yung hyperplane, how to create hyperplanes that can separate data. And there's also a video on how to simplify or to reduce the dimension of the data, because most data nowadays come in not only in just big volumes but also in big dimensions. So kung nung sinaunang panahon, sanay lang tayo ng matrices. So meron kang rectangular arrangement of numbers, and there is a certain interpretation for the entries of that matrix. Ngayon, multidimensional na yung data, more than 2 dimensions. So you can have a matrix of dimensions 2 by 2 by 2. So meron kang cubic arrangement of numbers. And this is particularly important if you are storing images. So hindi na ngayon 2-dimensional lamang yung pag-store ng images. High-resolution images are stored in, say, 3-dimensional arrays. Kaya lang, masanay tayo sa linear algebra na hanggang 2-dimensional lang yung array. So you need some techniques on how to collapse the 3-dimensional data that you have in a 3-dimensional array into a matrix. So if you are interested in that, or in the future, if you need to work with those data, at gusto nyong i-apply yung numerical linear algebra techniques, then you can watch the videos doon sa AMAT 255 website. All right? And basically, ganun lang naman. If you do your research, minsan papasok ka na parang wala kang ammunition papunta sa giyera, no? Meron kang isang particular topic in mind, you study the topic, and along the ways you will discover that kulang yung knowledge mo or hindi sufficient yung mga na-encounter mo or napag-aralan mong methods to address the problems in your thesis. So doon papasok yung self-study. You have to look at particular methods that you think will work. So magka-canvas ka sa literature, so you need to study them on your own. So part naman yun ng research. So basically kaya naisip ko, mag-focus na lang tayo sa isa or dalawang particular themes dito sa chapter na to, and then analyze it and study it in detail so that magkakaroon kayo ng experience. Ano yung gagawin nyo kapag kayo na lamang yung nag-aaral mag-isa ng specialized topics? Okay? Now, for today, we'll continue our talk about graph theory, but meron pa palang isang housekeeping matter. I still owe you 1 problem set. As promised, I'll do it over the weekend. I'll record a video para tulungan kayo dun sa MATLAB code. Tapos, I'll also share with you my code, so you just need to tweak the code a little bit. Modify it according to the data that will be given to you. So play with it, have fun with it. So siguro 1 hour or 30 minutes a day pwede nyo siyang paglaruan and then come up with a write-up towards the end of the semester. So I'll send you an email pag ready na siya. All right. Gagawin ko lang siya over the weekend. So that's it. And then for graph theory, hindi na ako magbibigay ng problem set. So baka magreklamo na naman sa akin si Ivy at saka si Ben Paul na ang daming problem set. Hindi, joke lang. Okay. So now let's continue. Let me share my screen. Tingnan natin yung graph theory methods na pwedeng gamitin sa network analysis. Okay, so I think we stopped here last time when we are talking about the distance between vertices, and this is just the usual notion of the distance, right? So titingnan mo ano yung pinakamaiksing path going from one node to another. So yun yung ilalagay mo sa distance matrix. So for instance, this entry in the distance matrix is basically the length of the shortest path from vertex 3 to vertex 1. All right? So tingnan nga natin vertex 1, ito si V1, tas ito si vertex 3. Now, the distance matrix tells us that meron ka dapat path of length 4, so we need to traverse 4 edges to at least 4 edges to reach vertex 3. And I think there are 2 routes. So pwede kang 1. O baka magreklamo na naman si Caleb, ano? Pero so 1, first edge, second edge, third edge, tapos fourth edge. So that's the path, the shortest path going from V1 until V3. Pero may isa pang route. So pwedeng pumunta ka sa 1, papunta kay 4, papunta kay 5, papunta kay 2, and then 7, 6, all the way to 3. But that would not be the distance because it will take longer for us to reach V3 from V1. So remember, the distance is the length of the shortest path connecting two vertices. And then, so this is a local property of vertices or nodes. So bawat isang vertex, bawat isang pair ng vertices ay magkakaroon ng distance. If you want to get a more global measure of distance, pwede mong tingnan yung diameter ng graph. So when you talk about diameter, siya ay parameter ng graph mismo. And the diameter is the largest distance between any 2 nodes in the network. So titingnan mo lang yung distance matrix, tingnan mo ano yung pinakamalaking number dun sa loob ng distance matrix. And that will be the diameter of our network. All right? So bakit ayaw mag-move ng aking slides? Okay, there we go. So in this particular case, tingnan natin yung laman ng distance matrix. Ang pinakamalaking number ay 5. So we will assign the number 5 to be the diameter of our graph here. Okay? And this is for the simple case that we have an unweighted, undirected graph. Okay? Pwede rin siya sa diagram. So pwede rin hindi pala ito digraph kagad. So paano kapag meron kang disconnected edge? Halimbawa, ito yung graph ko. Nagdagdag ako ng isang isolated na vertex, say vertex 8. Now, there is no path joining, say, vertex 1 to vertex 8. So, ibig sabihin yung distance mula kay 1 papunta kay 8 is assigned the value infinity. Right? Because there's no path. So, ibig sabihin walang way para makadaan ka mula kay 1 papunta kay 8. So, we assign the symbol infinity to be that distance. And when you have a disconnected node dun sa network, ina-assign na that automatically makes the graph diameter infinity. All right? So pero usually we don't want isolated vertices. So minsan tinatanggal na natin to dun sa ating network because this is not connected to everyone unless you're interested in taking into account what are the causes of that disconnection. Pero more often than not, we just disregard those isolated vertices. Okay. Okay. Now another global metric or a more global parameter for the graph is the average distance. Okay. So as the name implies, kukunin lang natin yung average distance. So meron kang distance matrix pero hindi natin isasama yung diagonal entries. Kasi yung diagonal entries, lagi lang siyang 0, right? Because that would be the distance of a vertex from itself. And you can just stay in your vertex para paano yan, mag-stay ka sa vertex. So basically, you can consider the shortest path from a vertex to itself to be the empty edge. So ibig sabihin, hindi ka naaalis dun sa pwesto mo, naroon ka na kay vertex 1, so yung distance ay 0. So to get the average distance in the graph, you just forget about the diagonal entries and then take the average between the entries or among the entries in the distance matrix. So makukuha mo yung average distance. So if you compute the average distance and if you get a small number, that means your vertices or your network are closely related to each other. Meaning maliit lang on the average yung kailangan mong daan ng path para makarating from one edge to another edge. Okay? So you can think of transportation networks, and then if your paths are unweighted, then that means that kapag ka maliit yung average distance, magkakalapit lamang yung mga nodes mo in the transportation network. Okay? Now, the concepts of path length, shortest path, diameter, average distance can be refined for digraphs and weighted graphs. So, halimbawa, if we compute for, say, anong magandang example dito? Okay. Halimbawa, we want to get the distance between, say, vertex A and vertex D. Halimbawa, ito yung gusto nating i-compute. Now, dahil digraph ito, i-consider natin mga paths, i-consider natin yung direction dun sa path. Alright? So, hindi na pwedeng back and forth kasi yung incoming edge ay iba sa outgoing edge. And now, the distance matrix will be non-symmetric. Unless laging may if and only if dun sa mga nodes, pero in general, hindi na symmetric yung distance matrix. So we need to consider kung ano yung direction ng edge. And secondly, it's a weighted digraph. So ibig sabihin may cost, may associated cost yung pagdaan sa bawat edge. So halimbawa, again, we want to find the distance between vertex A and D. So we need to take into account all paths that will lead from vertex A papunta kay vertex D. So in this case, ano yung mga makukuha natin? Well, I can start from A, go this route, but traversing this edge will cost us 4 units. Okay? So yung cost nito, meron na kagad 4. So lagay natin dito ay path to 1. So meron ka na kagad 4 units, tapos daraan ka dito from C to D. So that will cost you another 2 units. And then you will go you'll go this way. Sorry, yun na pala yun, no? Sorry. A to D nga lang pala yung kinocompute ko. So A to D, so this is 6 units. So the length of that path that we traverse, the red path, is 6 units. Kasi ko-consider ko yung weight doon sa vertex. Okay? Now, but there are other paths from vertex A to vertex D. For instance, we can go this route. Pwede akong from A, pupunta ako kay B. So let's call this path 2 or the length of path 2. So I'll have 3 units there. And then from B to D, I'll have 6 units. So this would be 9. So yung length ng second path ay 9 units. And are there any other paths? I think meron pa, pero mas mahaba na yon, no? So I guess here the distance between A and D will be equal to 6 units. Tama ba? I think so. All right. Just let me know kung hindi. Kung may nahanap kayong mas maiksing path. And you will see that computing distances between two vertices is a very tedious task. Ano? Medyo mahirap siyang gawin, especially if your network is very complicated, meaning you have many edges, you have many possible paths between any two vertices. Tapos kung may associated cost pa bawat isang edge, then that will give us some problems sa pagko-compute. But there's a classical. Ay, tama pala. Nandito pala yung example. All right. Now, there's a classical way to compute the distance between there's a classical algorithm to compute the hold on, bakit nawala siya? Okay. So nagkabali-baligtad yung aking slides. Pero there's a classical algorithm to find the shortest path between any two vertices. And this is just one of the classical graph theory algorithms. So marami pa kayo makikita ang ibang mga algorithms, but Dijkstra's algorithm ay isa sa mga magagandang exercises when you try programming in graph theory. And this algorithm assures us to find the shortest path. So I have here a description of the algorithm lifted from Wikipedia. Tama naman yung algorithm sa Wikipedia, so we can trust Wikipedia for this. So ito yung description, but I'll just illustrate it quickly. Wag na nating daanan tong algorithm na to. All right. So in this example, say we have this graph or this network, right? And then isa siyang weighted digraph. So mas komplikado yung problem because there are associated weights sa bawat edges, all right? So for instance, I want to start with vertex number 1 papunta kay vertex number, I guess, number 8. Kung tama yung pagkakalala ko dun sa example ko. So we want to find the distance between, or the distance from, kasi digraph to, so importante saan ako nagsimula papunta kanino. So we want to find what's the distance between vertex 1 and vertex 8. So kailangan nating tingnan, or kailangan nating i-compute yung mga lengths ng mga paths leading from vertex 1 to vertex 8 in a what you call this, in an efficient manner or in an orderly manner para ma-exhaust natin lahat ng possibilities. And Dijkstra's algorithm gave us a way how to do that, right? So the first step in the algorithm is we mark by 0 the starting point and assign infinity dun sa mga natitirang mga points. Placeholder lang muna yung mga infinity because now the labels doon sa mga vertices ay yung shortest path. Length ng shortest path mula doon sa starting point papunta sa kanila. So i-update natin yung mga infinities na yan, all right? Later as we go along in the algorithm, and the label for each of the vertices would be what's the length of the shortest path so far that we have considered from the starting point to that vertex. So let me just go back a little bit kasi mawawala ngayon yung pangalan ng mga vertices. So i-label ko lang sila. So ito si vertex 1. Tawagin natin tong vertex 1, vertex 2, vertex 3, 4, 5, 6, 7, first 8. Yeah, 8 is there. And then 9. So actually, Dijkstra's algorithm will not just tell us what's the distance between vertex 1 and vertex 8. Actually, ibibigay niya sa atin ano yung distance mula kay vertex 1 papunta sa lahat ng mga natitirang vertices. Okay? So yun yung titingnan natin. Paano nga ba siya gagawin? Again, step number 1, assign 0 to your starting point and then infinity to the others. Okay? Now, it makes sense that we put 0 as the label to the starting point because the shortest path from one vertex to itself is 0. All right? Or by default, 0 siya. Kasi hindi naman practically nag-matter ano yung distance mo mula sa sarili mo. All right? So it makes sense to put 0 in there. Now, the next step in the algorithm is to consider all the neighbors or all those nodes adjacent to the starting point. And then put as label to them yung distance mula dun sa starting point papunta sa kanila. All right? If there are multiple edges joining the starting point to another vertex, then you choose the smaller number. Okay? Halimbawa, isa lang naman yung adjacent kay or isa lang naman yung edge na nagmumula kay V1 papunta kay V5. Or actually, in general, isa lang yung edge na nagsisimula kay V1 papunta kay okay. Nagstay yung arrow. Hold on. Hindi ko magagawa pala yung laser tail ko. Pero anyway, kasi PowerPoint yung ginagamit ko. But anyway, so there's only one way to get out of vertex 0 or of vertex 1. And that is via this edge over here. All right? So isa lang yung adjacent from isa lang yung right adjacent mula kay V1. Medyo mahirap i-describe kasi digraph nga pala ito. Pero mula kay V1, isa lang yung pwede mong puntahan. Pwede ka lang pumunta kay V5. And the cost of going from V1 to V5 ay 4 units. Ito yon. So in this step of the algorithm, in the first iteration, I will label V5 by 4 because that's so far that's the shortest path that we have from V1 to V5. Okay? Tapos yan yung candidate natin. So 4 yung candidate na label kay V5. So it just means for now, so far, yung length na shortest length na na-consider natin from V1 to V5 ay length 4. And then pwede natin itong i-update later if we can find a shorter route from vertex 1 to vertex 5. Okay? Okay, in the second iteration, we will now look at all the outgoing edges from V5. Okay? Pero cumulative yung gagawin ko. Kasi remember, ang ating laging point of reference, our point of reference is V1. Gusto nating computen ano yung distance mula kay V1 papunta dun sa ibang mga nodes. So, ang gagawin ko ngayon ay mula dun sa lahat, so na kay V5 na tayo, sa lahat ng sa lahat ng incoming edges, outgoing edges mula kay V5, kukomputin ko yung cumulative distance papunta dun sa susunod na node. So for instance, from V5, we can go to 2 other nodes. So mula kay V5, makakapunta tayo kay V2 over here, tapos makakapunta tayo kay V6 over here. Kasi yun yung meron dalawang outgoing edges mula kay V5. So ngayon, si V2 at saka si V6, at least for now, I will label them by the cumulative cost of traveling from V1 until V2 and V6. Pero alam ko na, mula kay V1, papunta kay V5, kailangan ko na ng 4 units. From V4, papunta kay V2, kailangan ko ng 1 unit. So at this point, I know that to reach V1 to V5 via the path from vertex 1, vertex 5 to vertex 2, kailangan ko ng 5 units. So ililabel ko ngayon si V2 by 5. And similarly, I will label V6 by what? By 9. Kasi 9 units na yung kailangan kong gastusin para makarating mula kay V1 hanggang kay V6 via the path 0, vertex 1, vertex 5, then vertex 6. So that would be the next part of the algorithm. Okay? Tapos, kapag may pagkakataon na kailangan mong i-label, kailangan mong mamili ng bagong label dun sa isang node na non-infinity na yung or finite na yung label, pipiliin mo yung mas maliit because again, we are after the shortest length or the path of the shortest length from V1 until that particular node. Okay? So I guess ang sinunod kong ginawa dito sa slide, simula kay V2, tinignan ko lahat ng outgoing kay V2. So mula kay V2, meron dalawang outgoing edges. So first ay from V1 from V2 papunta kay V1. Pero if you go from V2 papunta kay V1, mag-incur ka ng 2 additional costs. So ibig sabihin kung dadaan ka sa cycle na V1, V5, V2, so kung dadaanan mo tong route na to, okay? Kailangan mong gumastos ng a total of 7 units. Excuse me, guys. So now we are confronted with a choice. Do I leave the 0 here or do I replace it by 7? Which is the distance again that I need to travel if I'm going to go the route V1, V5, V2, and then V1. Of course, pipiliin ko yung 0, which is the smaller number. So instead of putting 5 plus 2 here, leave ko siya na 0. Kasi hindi yun yung shortest path. Okay? And then what else? So from V2, we can go to V3. Pero the cumulative cost going from V1 until V3 via the route V1, V5, V2, then V3 would be 11. So in the next slide, you will see that V3 is now labeled 11. Okay? Tapos gagawin nyo to ng paulit-ulit hanggang makarating kayo, hanggang ma-label nyo lahat ng mga, actually hindi pala ma-label lahat ng mga nodes. Dapat madaanan nyo lahat ng edges para alam nyo na exhaust na natin lahat ng possible routes from V1 until any of all the other nodes. So if you're patient enough or if you're good at programming, you can just run your program and find the shortest distance. So makuha niyan 10 and so on. You label yung mga na-exhaust nyo na lahat ng mga possible edges. Okay? And then you continue the process until you're done. Okay? And this would be our final output. So this means that yung mga numbers dun sa mga nodes, ito yung ilalagay nyo doon sa distance matrix, all right? Column para kay V1. Kasi nga ang ating convention dito, ang starting node ay yung nasa column label, tapos yung ending node ay nandun sa row label. So, pwede nyo dito ma-construct yung distance matrix. Okay. So, if you are planning a route, say you're optimizing, say, the transportation cost, halimbawa meron kang trucking business or meron kang delivery business, gusto mong ma-minimize yung cost of traveling from the warehouse papunta dun sa gusto mong pag-deliveran ng iyong product, all right? Halimbawa, dito yung delivery point. I forgot the number. I think this is V8. So, hanapin mo ngayon yung path of length 15. Okay? Doon ka dadaan sa path of length 15. So, saan ba yun? Actually, you can work backwards, I think. So, ito yata yung shortest path na yun. Oops, and then here. So, this is the shortest path towards from V1 to V8. There's another route. The other route is this guy. So, you can go here. Almost the same route, pero didiretso ka na dito. Pero itong blue route is more costly because that will incur as 19 units compared to just 15 units if we traverse 6 vertices. Okay? So that's jig stress algorithm. Isa sa mga classical sa graph theory. So there are a lot of other algorithms that can give us some nice information about networks. So if you happen to need them, probably I can share with you some reference that I have in graph theory. Pero I think OR majors, isa to sa mga cornerstone ng optimization nyo in terms of discrete models. So yeah. So any questions so far? Wala pa naman? Okay. Now, balikan ko lang yung mga ini-skip ko na slides. Sorry, nagbalibaligtad yung slides ko. Pero here, let's look at another another measure, another graph parameter, which is basically, actually, hindi pala to graph parameter. This is a vertex parameter. This is the closeness of a vertex. So, ibig sabihin niya lang gaano kalapit on the average yung isang vertex mula sa iba't pang mga vertices. Alright? Gagamitin ko to mamaya sa ego analysis ko. So, the closeness of a vertex is basically the reciprocal of the sum of the distances of vertex U from all other vertices. So, kung meron kang distance matrix, kunin mo lamang yung reciprocal ng summation ng mga entries dun sa corresponding column ng distance matrix. So basically, this tells us on the average how far, or this is just the reciprocal, a multiple of the reciprocal of the average distance of a vertex from all other vertices. So ito yung gagamitin kong definition ng closeness Pero yung ibang references, ang ginagamit nilang definition ng closeness ay naka-multiply to sa n-1. Okay? Sa order -1. Para siya talaga ay maging reciprocal ng average distance. Pero this is just a scaling constant, so it doesn't matter too much. So hindi naman yung nagbabago when distance changes, so we can just forget about that extra constant. So basically for us, the closeness of a vertex is just the reciprocal of the sum of the distances of that vertex from any other vertex. Okay? Now, kailangan ko to or ginamit ko to dun sa program na i-share ko sa inyo in a few. But here's the background for that program. So, isa siyang parang ego network analysis. When we say you have an ego network, isa lamang siyang social network. Ito yung isang klase ng social network that we look at the influence of a certain individual, which we call the ego, and how he or she is related to the alters doon sa network na yon. So meron kang isang focal person. You call it the ego, and you look at how the ego is socially related to the alters or the other persons within the social network. So you can think of an ego, you can define several relationships for your ego network. So halimbawa, nung nag-thesis ako way back in the days, generate ko itong ego network na to. Ito yung ego network ng aking Facebook friends. Okay? So that means two nodes, each node here represents a person in my Facebook circle. And then two nodes are adjacent to each other if they are friends in Facebook. Okay? And then the nice thing about this network ay ano niya talaga. I mean, na-isolate niya talaga. Doon pa lang sa graphical representation ng graph, makikita mo na yung napakalimitado ng aking social network. Kasi parang meron kang dalawang major components in my friendship network in Facebook. So I think, if I remember it correctly, medyo matagal na itong data na to. Parang itong major component na to, these are my friends from UPLB. All right? So, mga co-faculty members, mga students na pinefriend ko pa dati, So, the big chunk of my Facebook network comes from UPLB. And then this second bunch of points, basically, ito naman yung mga kakilala ko mula sa Calauan. So, mula sa aking hometown. So, mga high school friends, mga family members, and so on. So, dun pa lang, makikita mo na yung classification ng data. Right? I forgot what the colors mean here and what the size of each node represent. Hindi ko na kasi mabalikan yung data kasi unfortunately tinanggal na ng Facebook yung API that allows me to download my friendship data, or at least yung API na kinocall ng Mathematica script na sinulat ko. I generated this using Mathematica. Tapos, meron lang certain line doon na kailangan kong i-connect yung Mathematica code ko online. So, sa Wolfram Cloud. Kasi Wolfram Cloud, meron siyang gagamitin na link papunta sa Facebook. Kasi bibigay ni Facebook yung friendship data ko kay Mathematica. Tapos si Mathematica, gagamitin niya yung data na yon para mag-come up ng graph na ito. Alright, so ganun yung proseso. Pero hinahanap ko yung, tinry kong i-run uli yung Mathematica code ko, ayaw niya nang gumana. And I think Facebook already discontinued yung API that allows me to download this such data or to access this data. Alright, so yun yung medyo downside nito. Kaya hindi ko kayo ma-require na paglaruan yung Facebook data nyo. Kasi I don't know if we have that data. Oh, yeah. That's how I gathered my data, Mitch. Pwede ko palang i-open yung chat. Ngayon ko lang nabasa yung question mo. But I hope that answered your question. So, yeah. Kaya lang, paano mo kaya to? I don't know if you can devise, siguro you can contact, say, a computer science major or programming major, ba kaya nilang gumawa ng program that will mine the data? Ano? Kasi ito, parang ano lang to, wala pa tong 10 lines ng Mathematica code. Kasi meron siyang social network toolbox na kayang connect kay Facebook. Pero ayaw na ngayon mag-share ni Facebook ng data. So there should be we should find an alternative way on how to do that. Because, of course, you don't want to do it by hand. No? Tapos doon pala, nung tinitingnan ko tong ego network na to, medyo napansin ko na, or nahalata ko na, meron akong mga isolated friends. Nung tinry kong tingnan, sino yung mga isolated friends na yun? Ibig sabihin, friends ko sila, pero wala na silang ibang friends doon sa network ko. Nalala ko, meron nga pala akong 3 pseudo accounts na kinreate para doon sa mga Facebook games ko. So meron ng isa para sa Cityville, merong isa para sa Cafe World, at merong isa para sa Farmville. Ang trabaho lang ng 3 accounts na yon ay para i-gift ako everyday. So ganun ako ka-addict dati sa Facebook games, and that shows in this network analysis because you have those isolated nodes in the network. Okay? Now, to illustrate how you can play with data coming from social media or how to analyze ego network and take advantage of the different graph parameters that we have encountered, naganap ako ng posibleng data set na pwede nating gamitin. Oops. Okay. And I found this data from the Stanford, I forgot the exact title. This is the Stanford data set. I forgot the exact name. Probably I'll just email it later to you. Meron silang ginawang survey ng 10 ego network. So meron silang 10 egos na kinonsider. These are actual persons, pero naka-anonymize yung data. So hindi nila sinabi yung pangalan. Basta may 10 persons silang kinonsider. And then they surveyed or they look at sino yung mga friends ng 10 egos na to. So, na-consider sila ng mga alters. Kinuha nila yung Facebook friends nitong 10 egos na to. And they considered 4,039 persons. Right? Ibig sabihin, meron siyang 10 ego network. So, in all, they got 4,039 nodes. So, doon sa 10 ego networks na yan combined. And there are 88,234 edges. So, meaning meron around 88,000 na friendship relation on the 10 ego networks combined. Pero dito mahalaga yung pre-processing. Kasi sabi natin sa data analysis, much of the bulk of the work happens on data pre-processing. Kasi nung tiningnan nila, yung data nila nakuha na hindi completely unrelated yung mga egos mula sa isa't isa and the networks from each other. So we didn't have disconnected ego networks here. So if I want to analyze the totality of those 10 ego networks, kailangan ko silang i-combine. But it turns out when you dig deep into the data, makikita mo na may overlap. So yung isang ego rito, posibleng friend siya ng isang friend ng kabilang ego. So ibig sabihin, may interconnection. So kailangan linisin mo muna yung data. Alright? So dun sa 4,039 na nodes na yan, merong repetition. So may mga tao na naulit kasi nag-appear sila in more than one ego and in more than one ego network. And it turns out yung isang ego ay pwedeng alter ng isang ego. I mean, yung isang ego ay friend din ng isang ego. So pwede mo siyang i-consider as an alter of the other ego. Kaya I think from 10 egos, naging 6 na lamang yung ego. Kasi may isang ego na friend ng isang ego, so mababawasan yung number of egos in this overall network. Okay? So ito yung ibang mga parameters ng data. So tingnan natin paano i-visualize itong data na to. Well, this is what you get if you run the MATLAB command. So if you will import all of the data, you will come up with this picture. So ito yung parang version nung Ito yung parang version nung Facebook friendship graph ko. Alright? Ito pala, nalagay ko. Stanford Large Network Data Set Collection yung ginamit. But don't worry, itong data set na to ay anonymized. So ibig sabihin, pinalitan nila instead of actual pangalan ng mga tao, inassign nila ng identifier number. tapos friendship yung ginawa nilang connections. In reality, you can define some other, or you can associate them using other relationships. Hindi kailangang Facebook lamang or Facebook friendship yung i-consider. Pwedeng two nodes are connected if they share the same political leanings. Ano? I think in this data, nandun sa data set na to kung Republican or kasi US-based to, kung Republican sila or Democrat sila and so on. So isa yon sa mga pwede nyong i-consider. Pero just for simplicity's sake, tingnan lang natin yung Facebook connections. Now, Facebook connection is symmetric in such a way that if I friended you in Facebook, then automatically you already friended me. So pwede natin itong i-consider as a simple graph. Kasi yung connection from this vertex to this vertex, alright, yung edge na yan, ay kaparehas lamang nung edge na pabaliktad. So because friendship in Facebook is symmetric. Medyo kakaiba kung i-consider nyo halimbawa ay ego network sa Twitter. Kasi influencers might be followed by other persons, but if you follow an influencer, that doesn't mean that the influencer also followed you. Doon magkakaroon ka ng isang digraph in the relation followed by. Alright? So siguro later pakita ko rin yung isang example ng digraph naman na network analysis. Okay? Let me see what's next in this slide. Okay. So maybe I'll shift now to MATLAB, right? Pwede ba akong mag-alt-tab lang dito? Okay. Okay. Now, I hope you see my MATLAB screen now. MATLAB screen na ba yung nakikita nyo o PowerPoint pa rin?
PowerPoint, sir.
PowerPoint pa rin? Sige. Let me stop share muna. And then, oh, sorry. Lipat ako na. Okay. Now, dapat MATLAB yung susunod na screen. Share screen. Talagang nangangapa ako sa Zoom. Okay, there we go. So now I have my MATLAB screen. So this is contained in the zip ba yun or RAR. I have a zip file that I shared in our website. So i-download yung zip file, then extract everything in one folder. Okay? So importante na nasa isang folder kayo, and then you open network.m. So open yung network.m, but make sure that nasa same folder yung iba pang mga functions na kasama nung zip pack na shinare ko sa inyo. Okay? Kasi tingnan natin. This is based on the blog written by Loren Shore in 2016. So basically, kinopy-paste ko lang yung kanyang code, and then I did a run-through of the code. Medyo binawasan ko lang yung mga comments. I think I added a couple of lines here, but essentially, ito yung ginamit niyang analysis or pang network analysis dun sa data mula sa SNAP or dun sa Stanford dataset. Okay. Now, I don't know if you guys are familiar with MATLAB, pero if there are some parts of the code that are not familiar to you or you're not familiar with the syntax, then pwede nyo gawin ay highlight nyo lang yan, tapos you can right-click on it and then get help, or just press F1 after you highlight a certain part of the code. Makikita nyo yung help page para doon. So, click mo yan. Makikita mo ano yung documentation para sa command na yon. Medyo mabagal mag-open yung help file. Oh, there you go. That's the help file. And this will tell you ano yung ginagawa nung command na yon. Okay? And then in MATLAB, kapag yung line mo ay merong %, ibig sabihin comment lang yon. So you can write your comments or labels for what that certain line is doing, all right? Hindi babasahin ni MATLAB yung mga lines or yung mga commands preceded by a % sign, okay? So line number 7, i-clear niya lang yung workspace, wala pang variables na involved. And then you have two options here. Ang susunod, pwedeng i-load mo yung FB data or i-run mo yung script na load FB data. So if you look at my folder in the leftmost panel, I have here FB, nandito ba siya? FB data. Hindi ko pala kinapi, pero there is Lauren Schur wrote a load FB data which will translate yung data set na mula kay Stanford into a MATLAB mat file. Ang file name kasi ng mga MATLAB data file ay .mat. So either you run load FB data, yung function na yon, which is also a MATLAB script provided by Lauren Schur. So ang gagawin niya, i-pre-process niya yung data na nanggaling dun sa Stanford dataset. Okay? I mean, hindi niya i-pre-process kagad. Ang gagawin niya lang ay i-convert niya into a MATLAB code or a MATLAB readable data file. And that is a .mat file. Pero ginawa na yun ni Lauren Schur for us. So ang ginawa ko na lang, dinownload ko na lang yung Facebook.mat. So kung makita nyo dito sa leftmost panel ko, doon sa current folder, merong file na ang pangalan ay Facebook.mat. This is a MATLAB data file. Nandito na yung MATLAB readable data na gagamitin ko para dun sa network analysis. Okay. Now, I'm not sure what the line or what the command who does. So, tingnan ko nga. Okay. Yung who, ginagawa niya lang, nililist niya lang yung mga variables dun sa workspace. So, dito sa output line, papakita niya lang ano yung mga available variables sa kanya. So I can run this lines. So pwede niyong i-run yung buong MATLAB script na to by pressing the run here at the topmost portion. I guess I can annotate my screen. Okay. So pwede niyo tong i-press, right? So i-run niya yung buong script, pero ayokong i-run yung buong script ng sabay-sabay kasi may dalawang parts itong script na to. So, ang gagawin ko na lang ay i-highlight ko yung mga lines na gusto kong i-run. Right? So, pag na-highlight ko na sila, tas ito lang yung gusto kong i-run, you can press F9, alright? Or, right-click ka, tapos evaluate selection in command window. So, ang i-run nyo lamang ay yung naka-highlight. Right? So, I'll press that. So, ito na. So, niload lang ni MATLAB yung nasa facebook.mat na file. At ang laman ng facebook.mat na file ay itong makikita yung variables dito sa right panel, yung tinatawag na workspace. So, the workspace will tell you ano yung mga variables na loaded kay MATLAB. So, whenever you write circles, edges in the command window, which is this portion here, ibibigay niya yung value ng variable na yon. Though, hold on. Bakit ganun yung itsura ng MATLAB ko? Putol yung variables. Pero, okay. So, I guess, palitin ko kaya to. Okay, there you go. So, nandito rin sa workspace yung preview kung anong klaseng variable yung nandun sa anong klaseng data yung nandun sa variable na yon. For instance, if I type circles in the command window, so ito yung command window, pwede ka dyan mag-run as if you're doing using a calculator. So pag ginawa ko yung circles, press enter, ipapakita niya yung laman ng circles na variable dun sa workspace. But this is a multi-dimensional data because it's a cell, all right, or it's a structure. So pag kinlik niyo yung circles sa workspace, pwede mong i-double-click, ibibigay niya sa atin yung itsura ng variable na circle. So anong yung laman ng variable na circle? And it will tell us this is a data structure. Pag kinlik mo yung laman ng cell na yan, makita mo yung specific laman ng structure na to. Halimbawa, ito, i-click ko itong 9x308 double, ibig sabihin isa yung 9x308 matrix na ang laman ay mga double precision numbers. So if you click on that, you will get this matrix. And I don't remember what this numbers stand for, all right? Ang alam ko lang, dyan na makukuha yung data. So we can always go back and dig deep into this code para maintindihan yung bawat step. Pero we are now looking at it from a bird's eye perspective, tingnan lang natin kung paano ginagawa yung network analysis. Yung coding, kaya nyo na yung pag-aralan later. Okay? So I'll clear the annotation, close the workspace variable, and then I'll go back to my MATLAB file. Okay, ngayon i-visualize natin yung combined ego networks. So itong lines 18 to 24, ito yung data cleansing. So ito yung pre-processing na ginawa. So kasi nga dun sa data, napansin nila na merong repetition yung mga nodes. So tinanggal lang nila yung mga repetitive nodes. Tapos tinanggal nila yung mga unconnected nodes. Yung mga isolated nodes na ibig sabihin nung unconnected nodes, ibig sabihin na survey siya pero hindi naman siya friend ng mga egos or hindi siya connected sa kahit na sinong alter. So pwede natin silang tanggalin kasi kung i-maintain natin sila dun sa network, ang magiging distance na or magiging diameter na nung network natin ay infinity kasi they are disconnected from the egos and the alters. Alright? So yun yung gagawin ng lines 18 to 24. I'll hit 9. I'll hit F9 para i-run ni MATLAB yung lines 18 to 24 after highlighting, of course, 18 to 24. And then, etong edge, see, ito lang yung edge color. Ito yung, I think, RGB coloring na pipiliin niya para dun sa pagkukulay ng mga edges. So I'll just run it again para lang iset. And then lines 28 to 39, ito na yung i-graph na ni MATLAB yung ating ego network. Okay. Where the egos are highlighted in red. Okay. So yung makikita nyo sa lines 38 to 49, I'll hit enter or I'll hit F9. Okay, makikita nyo na itong figure na ito. So let me just maximize this. So ito yung ego network na makikita natin, though medyo hindi maganda yung scaling kasi napakarami ng nodes. So from 4,000 plus na original nodes doon sa 10 ego network, merong mga overlaps. So na-reduce na sila sa 3,959 nodes. Tapos yung edges na bawasan din, around 84,000 na lang yung edges. At nagkaroon na lang tayo, I think we only have 6 egos. Kasi nga yung 4 dun sa mga original egos ay alter din pala nung ibang egos. So pwedeng pumili na lang ako sa kanila kung sino yung i-retain ko as an ego. Right? Now, you can do a lot of things with the MATLAB figures, so you can explore it later. Well, one thing that I want to do in this figure is to magnify and zoom in into the graph. Kasi kung makikita nyo, ito yung major component. Alright? Kasi rito makikita nyo, etong dalawang taon na to na na-survey, friends sila ng isa't isa, pero hindi sila na-reach ng mga ego. So you can imagine this to be, say, an analysis of how influencers work. So kung isa akong company and I want to look for an influencer, gusto ko yung influencer na yon ay malaki yung reach or marami siyang friends na friends din. Meron siyang friends na marami ring friends. So para pag nag-post siya, maraming makakita nung post or nung advertisement na ipapashare ko sa kanya. Alright? Now let's see. You can click the plus sign button here, the magnifying button here. Ito. So if you click that, magbabago ng itsura yung cursor. My cursor now is a plus. Tapos pwede kang mag-highlight ng rectangular portion kung saan mo gusto mag-zoom in. So dito ako mag-zoom in. Okay, makikita ko yung itsura ng network. And of course, it's not easy to visualize this kasi 80,000 plus yung ating edges. So nag-overlap yung mga edges, but this is the best representation MATLAB can give us. Right. So zoom in pa ako. Right. So makita nyo, ito, meron akong node dyan. Ito pa yung isang ego. Tapos ito yung mga alters. Iba't ibang mga alters yung nandyan. And there's a lot of connections here. So ito yung mga friendship connections. And imagine, if you will be doing this by hand, hindi ka matatapos, or it will take you years. Pero thanks to technology, kayang-kaya nating i-visualize itong napaka-komplikadong network nito with just some commands. With just a hit of a button, we're going to get this representation, at least a visual one for the network. Okay. So now I can right click and then ask MATLAB to restore the view para bumalik na ako ngayon dun sa ating network. All right. Dun sa bird's eye view ng ego network. Now, what are the things that we can do with this ego network? Well, we can look at, say, degree centrality. Ano? Pwede nating tingnan gaano ka central yung isang ego. Meaning, we will look at the degree of the ego. Or, halimbawa, I think here, kukunin ko yung top 3 nodes with the highest degree. Remember, yung degree ay yung number ng vertices na adjacent sa kanya. So, mas malaking degree, ibig sabihin siya ay mas connected. All right? Or marami siyang ma-reach kasi siya yung maraming friends. Okay? Now, iba pala yung ginawa dito ni Lauren. So, una, pumili siya ng ego node. So, halimbawa, kinonsider niya yung second ego node. Tapos, tiningnan niya, sino dun sa mga alters ni ego number 2 yung may pinakamaraming friends. Kinuha niya yung top 3 nodes connected to ego 2 with the highest degree. So, you can change the index here. You can change IDX into the ego number that you want. So, you can play around with this. Makikita lang natin na yung ego IDs, right? So, ego IDs, itong variable na yan, siya yung vector na nagko-contain ng ego numbers or yung labels para dun sa mga egos. If you highlight ego IDs and then press F9, lalabas dito sa command window yung mga egos na meron tayo. So, si node number 0, siya yung unang ego. Si node number 107, siya yung susunod na ego, and so on. So in this particular case, I am analyzing who are the top 3 followers ni ego number 107. So ang gagawin niya, kukunin niya lahat ng connected kay ego number 7, tapos kukomputin niya yung degree ng mga connected kay ego number 7, tapos titingnan niya sino yung top 3 na maraming friends dun sa mga alters ni ego number 107. Okay? So you can run this, okay, together with the figure, all right? So yung figure, tingnan natin kung anong ibibigay sa atin. So, okay. Highlight ko lang hanggang line 74, and then I'll hit F9. And then ito. Ito yung ego network ni node number 107. So, mas kakaunti na ngayon yung nodes at saka yung edges kasi ito lamang yung network ni node number 107. So halimbawa gusto kong makahanap ng second influencer. Halimbawa si node number 107 gusto kong kontratahin pero ang laki nung hinihingi niyang bayad. Pero nung inanalyze ko yung network ni person 107, nakita ko na meron siyang top 3 followers or top 3 friends na malaki rin yung reach within the ego network of person 107. Kung hindi ko afford si influencer person number 107, ang i-hire ko na lang or ang titingnan kong posibleng i-hire as influencer ay si alter or si person number 1888, person number 1800, and person number 1663. Kasi sila yung tatlong friends ni person 107 na may pinakamarami pang friends. Okay? And the nice thing about this figure ay pinapakita natin yung degree nung bawat node using the color scheme. The more purple the label or the more purple the color of the node, the more friends it has. All right? Kasi nga yung degree yung mini-measure natin dito. So yung kulay ng bawat node, siya yung degree. So syempre, pipiliin mo yung mga purple. All right? So if we zoom in into one part of this code, so punta tayo dun sa malapit kay number 2 and number 3. So, tingnan ko nga. Okay. Medyo mabagal lang. Oops. How do I do this? Sorry, restore ko muna yung view. Tapos mag-resume ako dito. Kailangan ko siyang antayin kasi medyo bagal. Okay, there we go. So, ito yung top three performers or top 3 alters ni Ego number 107. So, ito, saka ito. So, sila yung mga pinaka-purple yung kulay among all of the nodes. Okay? So, ito, dahil itong node na to ay medyo bluish yung color, light blue yung color niya. So, ibig sabihin, kukunti lang yung friends niya within the network. So, pag nag-share siya ng isang post, mas kakaunti yung makakakita. Okay? Of course, in this Ego network, si node 107 yung may pinakamalaking degree kasi by definition, Ego network niya to. So, lahat ng mga nodes dito sa network na to ay connected kay node 107. So it doesn't make sense na isama pa sa comparison si node 107. Kaya ang ginawa ni Lauren, hindi niya na-count si Ego number 107 dun sa pataasan ng degree. Kinuha niya lang yung top 3 followers or top 3 friends in terms of degree centrality ni Ego number 107. Okay? So in this analysis, sila na lamang yung kukontratahin ko, baka mas mura yung talent fee nila as influencers. And anyway, I will get a good portion of the network of node 107 in this Ego network. All right, I'll have access to those members or to that portion of this Ego network. Okay? Now, tingnan natin kung ano pa yung pwedeng gawin ng code na to. And again, you can play with this. You can just change the index number. Index number, it's from 1 to 10 kasi 10 naman yung ating egos. So you can take a look at ego number 8. Tapos i-run muli yung lines 53 to 60 to 78. Sorry, wag yung 78. Hanggang ano lang pala, 73. Press F9. And then I'll get the ego network for the 8th ego, which is person number 414. So makita nyo, mas ito yung itsura ng kanyang network. Right? And then the top 3 followers or the top 3 friends of ego 414 are persons 376, 373, and 513. Okay? Kaya lang yung maximum degree ay around 55 lamang. So yung top alter ni ego 414 ay meron lamang around 55 or around 57 friends. Okay? Pero nevertheless, medyo maliit kasi itong ego network ni person 414 kaya sa kay person 107 natin kanina. Okay? So, play with the code. And then if you get interested and later na-realize nyo, kailangan ko pala itong ganitong analysis. So, saka nyo balikan at tingnan in detail ano nga ba yung ginagawa ng bawat line nitong program na to. The thing that I appreciated with this program, hindi nagtipid si Lauren sa comments. Kasi marami siyang comments na nilagay na nag-explain nung ginagawa ng bawat line ng code. And this is a good programming practice, lalo na para maging user-friendly yung inyong program. Kasi probably isa sa mga drawback ni MATLAB, hindi maganda yung user interface, So it's really for a developer. Of course, you can devise, you can create a front-end user interface para rito, pero that's another thing to study. Pero kung ako lang naman yung gagamit for my research nung MATLAB command or nung MATLAB code, I'm contented with this setup. Actually, kung mas gusto mo siyang gawing parang Python notebook or ano bang tamang term? Jupyter notebook ba or Python notebook or whatever notebook it is, So pwede naman siyang MATLAB live file. I-save nyo lang yung .m as .mlx. May kita nyo yung ganito yung itsura niya. So para na siyang notebook where the comments are typewritten in a nice way or are typeset in a nice way. As if you have a book here. And then the nice thing, it's a live code. Pwede nyong i-run yung bawat section. Para mag-start ng isang section sa code, kailangan nyo lang ng double percentage. So limbawa, itong visualizing Facebook networks with MATLAB, ito yung first section ng code. And in the source code, siya lamang ay double percent sign yung ginamit. Kapag ka single percent yung ginamit nyo, iti-treat lang siya ni MATLAB as a usual text or a paragraph or an introduction, right? So ito yung live version ng code ni Lauren. All right, sinave ko lang as .mlx yung .m na ginagamit natin ngayon. So if you want to make it more user-friendly, then probably this is the easiest way to create a user interface. Pero yeah. Pero may mas app-looking na way on how to package your MATLAB program. Pero hindi na ako familiar doon because I don't have time to study how to do or how to make a user interface for my MATLAB code, right? But if you want to commercialize your code or apply patent for it, mas okay na meron kang user interface. And I think MATLAB has a good package on how to write a user-friendly code. Okay. So, and then one nice thing is we can also, aside from looking at the ego-centered parameters of the graph, kasi so far yung ego analysis na ginawa, yung degree analysis natin ay ego-centered or local-centered. Kasi meron tayong isang ego network, tinignan natin yung degree ng bawat member ng ego network na yon. If you want to get a more holistic view about the entire combined network, so yung buo na nating network ng 10 egos, so 6 na egos, pwede nating tingnan yung degree distribution. If you remember, ito yung diniscuss natin last time na may Poisson, may exponential, may scale-free or power law distribution. Pwede ko rin ipagawa kay MATLAB yung klase ng distribution. Yun yung ginagawa ng lines 75 hanggang lines 96. Gagawa siya ng histogram ng degree distribution. So I'll hit F9 after highlighting all the necessary lines in the code, then I will get this degree distribution. Okay. Now, in this particular case, ito yung degree distribution ng ego network, ng combined ego network. So yung the total of 4,000 plus edges, tama ba? 4,000 plus, just below 4,000. Ito yung 3,900 plus na mga nodes, yun yung kulay blue na histogram. So ito yung degree distribution, yung kulay blue ng combined 10 ego networks natin. So this means that kung titingnan natin yan, there's around pag hinover mo yung mouse mo, yung pointer mo rito, sasabihin ni MATLAB, there are 885 nodes na ang degree ay between 0 and 10. Okay? Tapos itong second bar here tells us that there are around 801 nodes na ang number of non-degree ay between 10 and 20. You can play with the histogram command kay MATLAB. Pwede mong paliitin yung width ng bawat bar graph. Pwede mong gawing 0 to 5, 5 to 10, and so on. You just play with the parameters ng histogram command. Pero by default, kasi 10 yung length ng histogram. And you see that it resembles a power law distribution or a scale-free distribution. Kasi parang pag ganito yung kanyang distribution. Majority ay kakaunti yung degree. There are just some outliers here. If you go here, meron ba? Yes. I think merong maliit na portion dito na... Okay, there you go. Hindi ko makita yung data. Pero probably I can zoom in. 0 pala doon. Kaya hindi ako makapag-zoom in. Okay, so dito, makikita ko na there is one node that has a degree between 250 and 260. All right. So sila yung parang pinaka-influential, ano? So here meron dalawa na between 290 and 300 yung kanyang degree. So I think those are the most influential among the the egos in our graph. Or actually, not just the egos, but also the egos and the alters. Okay. So, and then the orange part, let's see. Hindi ako maka-right click. Bakit? Gusto ko siyang i-restore. Okay, there you go. The orange one here, or anong kulay ba to? Yung parang kulay brown, siya naman yung ego distribution para kay node 414. Alright? So para kay ego network 414, yun yung degree distribution niya. And I guess here, mukhang Poisson yung distribution niya. Alright? Kasi pag ganito yung distribution niya nung kanyang degree distribution. So here you can have an idea that the combined network, as most social networks, ay power law yung distribution na pina-follow. While if you look at smaller networks, posibleng hindi power law yung makuha nyo. In particular here, node 414 has an ego network with almost a Poisson or probably a Poisson distribution. Okay? And then you can search in literature, ano yung implications kapag ka-power law yung distribution niya. Then you can look at what's the exponent or what's the normalization constant of that power law distribution. And then you can interpret it in several ways. Okay. Now, let's see what are the other things included in the package. So, yeah. Okay. Now, you can also modify. Kasi eto pala, yung combined ego network, tas pwede ka ditong mag-decide sinong specific ego yung gusto nating makita yung distribution on the background or in the foreground of the total network degree distribution. Sa limbawa, gusto kong tingnan kasi kanina si ego, who's that ego? Ego 414. Yung kinuha natin yung kanyang degree distribution compared to the combined ego networks degree distribution. So, halimbawa, gusto ko naman tingnan si ego 107, which is the first in our list, or I think the second in our list. So, gawin ko lang na si index, IDX, ay gawin kong equal kay 2. Alright? So, makikita nyo rito, i-call ni MATLAB sa line 91, or actually, ililabel ni MATLAB yung ego network or yung degree distribution ng ego network ni ego number 2. Okay? Yun yung gagawin niya rito. So I'll rerun that part of the code. Tapos, dapat na makikita ko na ay ego distribution, degree distribution na ni ego number or ni person number 107. Though I'm not sure kung nabago siya. Combo 107, 122. Tingnan ko nga yung figure 4. Okay. May pinagbago ba yung dalawa? Combo 25, node 22. I guess hindi siya na-update dito. Sino yung histogram? Hindi nga siya na-update. Kasi ang kinol niya lang ay yung histogram ng degree ni graph G. Pero hindi ko ni-recompute si graph G sa lines 82 to 84. So kung gusto kong i-recompute si graph G, kailangan kong balikan ito. Kasi kukunin ko yung graph corresponding to node number 2. So dito pa lang kailangan ko nang baguhin yung index ko ay number 2 para ma-generate niya yung ego network ni ego number 2, which is person number 107 sa list. Tatawagin niyang graph G yon. Tapos yun yung bibigyan natin ng degree distribution dito sa ilalim. So copy, highlight everything and then press F9. Okay, there you go. We get a different degree distribution. Ito na yung tamang degree distribution. Ito yung degree distribution ng ego network, ng combined 10 ego networks, and the degree distribution of the ego network of person number 107. Okay? So, medyo pwede mong tingnan as mas friendly yung mga nasa ego network ni node 107 because the median degree ng mga nasa node 1 dun sa ego network ni node 107 ay 36. Ibig sabihin, the median of the degrees of the alters of ego number 107 or node number 107 ay 36. Meanwhile, ang median nung 10 ego networks combined ay 25 lamang. So you can think of lahat ng nasa network ni person number 107 ay mas Facebook friendly than the entire population. Okay? Tapos, and then you can look at the degree distribution of the ego network of 107, mas power law yung datingan niya, right? Kasi yung graph niya, nire-resemble niya yung P sub K equals CK to the negative alpha, where alpha is a number from 2 to 3, all right? So ganon yung itsura ng graph niya, which follows yung distribution ng degree no combined ego networks. Okay? So yeah, play with the code. And then I think the last part is basically a play on MATLAB's data. And then may shortest path pa pala siyang ginawa. So dahil 3 minutes na lang or 2 minutes na lang, so I'll let you guys play with this part. Pakita ko lang, papakita niya yung shortest path. I won't go into details. Pero the nice thing about this, MATLAB can find the shortest distance or the shortest path. So effectively giving us the distance between two paths, two vertices. So tiningnan niya yung top node at saka yung node 483. Ano yung shortest path between them? Kaya ni MATLAB yan. Dalawa lang or 2 lang yung distance between the top node and node 483. And the nice thing is MATLAB can show us what is that path exactly. And in this particular figure, pakita niya na dadaan ka lang kay person 1086 para makarating mula sa top node. Who's our top node? Si top node ay node 1888 with degree 253. Kaya niyang ma-reach si person 483 via person 1086. So, pwede mo tingnan yung shortest path dito. Ilang reshares yung kailangan. Ilang share ng post ang kailangan para makarating kay person 483. So, ibig sabihin, at least or on the least, kailangan mo lang 2 sharers para makaabot kay person 483 yung advertisement mo. Mag-share si top node, makikita ni 1086, hopefully person 1086 will again share that post. Makakarating ka ngayon kay person 483 at the shortest. Of course, there might be other longer paths from the top node to node 483, pero ito na yung best case scenario. Okay. Tapos lastly, tiningnan ngayon ni dami palang ginagawa ng code. So meron ding centrality. Centrality ay nandun sa last portion nung PowerPoint presentation, which I already uploaded a copy of. So if you want to look at what is centrality, what is the closeness, so balikan nyo na lamang yung PowerPoint presentation. And then may challenge si Lauren. Pwede nyo raw use your own Facebook data, pero yun nga ang problema, discontinued na yung API na ginamit ko dati. So hindi ko sure kung meron ng alternative way how to download your Facebook data into something that is usable in terms of MATLAB or Mathematica code. Pero meron daw isang app na kayang tingnan naman yung page-like network. So kaya niyang i-generate yung directed graph nung pagla-like. So halimbawa, meron akong page, nilike ko yung isang page, so magkakaroon ng outgoing edge from my node to the like page node. So dahil yung pagla-like ay ng isang page ay hindi symmetric. So pwede mo siyang i-model as a digraph. Yun yung tiningnan nila dito sa part ng code na to. Kinuha nila yung data mula dun sa app, sa isang Facebook app. I don't know if this is still active. This code was written in 2016. So baka posibleng wala na to ngayon kasi yung thesis ko ay sinulat ko noong 2014 or 2015. Na-harvest ko pa yung data ko galing sa Facebook Tapos ito 2016 active pa. I don't know kung active pa to. Pero nagawa nila to para sa MATLAB. So kinuha nila, tiningnan nila yung like relationship nung MATLAB page, MATLAB Facebook page. So tiningnan nila sino yung mga ni-like ni MATLAB Facebook page, and then sino yun naman yung mga ni-like nung mga ni-like ni Facebook MATLAB page. And then the analysis goes on, tiningnan nila yung buong network. So yung ego network na to, ang nodes niya ay mga Facebook pages, and two nodes are connected to each other if, or node U has an outgoing edge to node V if page U like page V. Alright, so yun yung relationship dito. Tapos ang ego dito ay si MATLAB page. Tapos ang alters ay yung mga pages na nilike ni MATLAB at yung mga nilike na mga pages na nilike ni MATLAB page. Okay. So let's see. Meron lang silang ranking na ginawa with, I think this is degree, incoming degree. So incoming degree, so tiningnan nila sino yung mga alters ng MATLAB page na may pinakamaraming likes within the ego network. Tingnan nila yung top 5. Pero for whatever reason, hindi ko makita yung buong figure. Alright? Pag niran ko tong lines na to, ito yung makikita ko. Ang maganda rito sa graph na to, hindi naka-anonymize yung data. Alright? So bawat isang node dito will correspond to a Facebook page na either ni-like ni MATLAB or ni-like ng isang page na ni-like ni MATLAB. Alright? For instance, this node over here, okay? Yung node na yan ay National Society of Black Engineers. And then this one is, tingnan natin kung ano to. Ito ay Engineering TV. So, ang in degree niya ay 8. Ibig sabihin, merong 8 nag-like kay Engineering TV within the ego network at meron siyang 4 na ni-like within the network. Right? So, here, yung coloring scheme, the more purple your node is colored, so mas malaki yung in degree mo. Ibig sabihin, maraming nag-like sa'yo. And the code highlighted yung 4 na pages or yung 5 pages na pinakamaraming nag-like. NWS, I think this is the National Weather Service. Yeah, that's right. Ng US. And then NOAA, ito ay National Oceanic and Atmospheric Administration. Of course, si MATLAB siya yung nasa gitna. So meron siyang 11 na nilike at may 11 nag-like sa kanya within the network. Pero talo siya ni NWS kasi within the network, merong 13. Meron siyang 13 in degree tapos 11 out degree, which gets me confused. Bakit ang laki ng edge? Ang laki ng ano dito? Ang laki ng scale. Parang hindi nagma-match yung color dun sa scale. Make Magazine. Make Magazine. Oh, there you go. Make Magazine has 104 in degree and 139 out degree. So maraming nilike si Make Magazine, tapos 104 yung nag-like sa kanya, which makes it the most like page. Ano ba yung most like? Yeah, I think this is the most like page within the ego network of the MATLAB page and so on. Right. So, ang dami nating nakuhang insights mula dito sa graph na to. And basically, you can say, meron dalawang major components sa itong network na to. So, you can say, this is sort of almost a click in here. Meron silang sub-network dito. Tapos dito meron ka pang isang halos meron ding sub-network. Alright? And this will give you an idea paano ka mag-place ng ads or how can you boost your following and so on. Okay. This would be a nice exercise sana, kaya lang I don't know how we can harvest the Facebook data. And I don't know ano na yung itsura ng data na ibibigay ni MATLAB, na ibibigay ni Facebook o ng Facebook app, kasi kailangan ko pa siyang i-pre-process. Kailangan ko siyang i-convert into a .mat file, which is the data file read by MATLAB, before I can do everything here. Pero if you will be doing network analysis, you want to do it in MATLAB, then that would be a problem for you later. All right? Saka na lang natin aralin kung paano siya gagawin. Alright? But I think we can stop here. That's just a taste of how network analysis can be done using a program like MATLAB. We have a free subscription to MATLAB, so sayang naman. So i-download nyo si MATLAB. Doon nagkakaproblema ako sa 22B, the latest version. Nung nag-update ako, bumaba yung graphics, bumagal yung graphics ko. Maybe either it is due to MATLAB or dahil nag-update ako ng laptop. Pero yeah, hanapin ko pa siya. Medyo bumagal kasi yung graphics generation ko in the latest version of MATLAB. So may nagulo dun sa system ko. Pero hopefully hindi siya si MATLAB yung problema. Okay? Okay, so let's stop here. Sorry, overtime na naman ako by 7 or 8 minutes. Do you guys have any questions? Quick questions? All right, so kung wala naman, so thank you guys for joining me today. I'll double check the schedule, but I think it will be Sir Jomar who will be taking charge of the class next week. But I'll be back for a couple more chapters. And yeah, until then, work with the problem sets that I already gave you. Watch out for the next problem set. And then let's see each other again pag schedule ko na. All right? Bye guys. Enjoy the weekend.
Bye, sir. Thank you.
Thank you po.
All right.
Thank you po, sir.
You're welcome, guys. And meeting ko na.